everyone, welcome back. In this particular video, we will be discussing the problem find the longest substring with at most k distinct characters. So this problem will be a problem based on hashmap plus two-pointer technique. So if you don't know the basics of the hashmap data structure or the two-pointer technique, first you should know the concept because that will be a prerequisite. We are given a string. We need to find the length of the longest substring, that is a part of a string which is contiguous, all the characters should be consecutive. The length of such substring which is longest, but the constraint is it should contain at most k distinct characters. There should be no more than k different characters. Even if the characters are there, uh, the number of different characters you can say should be only k, and there should also be obviously no repeating characters because it is saying that the k distinct characters should be there. So we can assume that there will be no repeating characters. Or let's say actually in the example whether we have to include repeating or not. So the note is uppercase and lowercase characters should be considered as different characters. That is, capital A is different from small a. We have to just keep this in mind. And also, there can be number special characters as well. That is, there can be any ASCII code present in the string. It can have underscore, dollar, hash, anything. So what we are given is, we are given two values, n and k. N will be the string's length, k will be the value which we need to basically do for the validation. That is, we have to find a substring with at most k distinct characters. So k is also needs to be given in the input, and also of course the string will be given. So if I take the string having 5 length, the string is a, b, a, c, d, and the k value is 3. So if I just write the string again, a, b, a, c, d, k value is 3. What is the substring with at most 3 distinct characters? The answer they are saying is of 4 length, that is having string a, b, a, c. So actually, as you can see in the example input, we have to include repeating characters also. If we can include repeating characters, no problem, we can include it. But whatever characters we are including, the count of different characters, distinct characters should not be more than k. As you can see, the answer which they are saying a, b, a, c is of 4 length, and it is only having 3 different characters, a, b, c. If you want to include d, you have to exclude a also from here also. So in that case, the string will only become 2 length, which is not the maximum length. So that's why the answer is 4. If I take the second example, which is having string capital X, small y, z, small y, a, and the number of distinct characters which we need is k is equals to 3. If I take capital X, if I take small y, then I can only take still y, small y, that is z also. So in this case, there will be 3 distinct characters. We can't take a, and what will be the length? The length will be 5. That is what the maximum length is. Or you can also take, instead of capital X, you can also take small a. Even though if it was not small a, even if it was small x, still it should be only 5 length. Why? Because capital X is different from small x. We have to treat them differently. That is what given in the question also. So any brute force solution which we can just directly think of, most of you will also be able to think of, is that how about generating all the substrings? Because we have to find the longest substring. Let's just first generate all the substrings, and out of all the substrings, we will check whether they are following the constraint or not, whether the number of distinct characters are only k or at most k or not. If yes, update the maximum answer. If not, do not update the answer. So to generate all the substrings, it will require 2 nested loops, or you can say one loop as outer loop for start pointer, another loop as inner loop for the end pointer, the starting and ending index for the substring, where the substring is starting, where the substring is ending, that will be n square. But to count the number of unique characters, it will have the third loop. So overall, it will be 3 loops, n cube in nature. Although what you can do is you can try to optimize it and combine the third loop within the second loop only. That is, while you are running the loop for the right pointer, while you are including characters, you can just also count how many unique characters are there. So that would require order of n square time complexity. 2 loops will be there, which are running for the entire string. So without using any extra space, we will be able to do this problem in n square time complexity. But as you can see, n is very large. N is 10 to the power 5. It might go into time limit exceeded if we are just going to follow the brute force. We are not going to go into that. We are going to optimize it further. But when it comes to optimizing it further from n square, what we have to do is we have to maybe run a single loop only. Either two solutions exist, either n log n or n. So let's try to actually think of a solution in linear time complexity. Now, what do we need to do when we are just running a single loop? While running the loop, we have to maintain the count that what are the number of repeating characters, what are the number of unique characters. So for that, let's just take a string. Let's just take this particular string. And in the string, let's also take the value of k, which is 3. We want only 3 distinct types of characters in our string, or maybe let's take 4 distinct characters for that matter. And we need to count the longest substring, which is only having 4 different types of characters. So while we are including characters, what we need to also basically maintain is how many unique characters are there in the current substring. While we are including A, there is only one unique character, so good. At most 4 should be there. While including B, at most 4, yes. 3 is less than equal to 4. Again, 3 is less than equal to 4. Again, 4 is less than equal to 4. But as soon as I include E, it is now more than 4. The number of unique characters are 1, 2, 3, 4, 5. So now we have to exclude the characters. And in order to exclude the characters, since we are including from the right side, better will be to exclude from the left side. Why? Because obviously the pointer to include will keep on including the elements one by one. But if I will exclude it from the same side, we will go back to the previous step and we will just be stuck in an infinite loop. That is, again, you will include one element, then again, you will say it is having more characters than 4, discard it, again, include it, discard it. So, in order to just keep moving, just do not go into infinite loop, let's discard the element from the other side, that is from the left side. So we will discard A. As soon as you discard A, number of unique characters again come out to be 4 only, at most 4. Then you can include, you can start again including F. As soon as we include, we have to again discard. And if we are going to discard B, the number of unique characters 1, 2, 3, 4, 5, it will be still 5. So we have to discard all the occurrences of B. That is, we have to discard this C also because we need a substring. We can't just discard this character and this character. So we have to discard both of these characters. Then only we will say the number of unique characters will be less than equal to 4. So since we need a pointer to include characters, let's say this is the right pointer, which is used to include the characters. And we also need a pointer to discard the characters. Let's say this is a left pointer. So there will be a 2-pointer approach. Both of these pointers will be managing a window, a substring. So it is going to be known as a sliding window technique, and that too of a dynamic size. So it will be a dynamic sliding window approach. But to know what is the last occurrence of the current character or what is the last time a different character was found, we have to basically just keep on discarding the elements till we are getting the same element. See, if I am saying for F, when I am including F, I have to discard the elements till I am getting the count back to 4, the number of unique characters count back to 4. So I have to get the frequency of each character. That is, what is the last time the current character was occurring, or how many times the current character was occurring in the current substring. And not just the current character, but every character in the substring. How many times are they occurring? So that we can know whether the substring is having less than equal to 4 characters or more than 4 characters. And for that, we are going to maintain one data structure which will just store the frequencies of each element. And that data structure which will store the character with that frequency, a key value pair, will be a hash map. So we will maintain a hash map in which searching is also very easier and also insertion is also easier. Hash map will have the character for which the frequency needs to be stored as the key value, as a key actually, and the value will be, you can say, the frequency, that is an integer. Initially, a hash map will be empty. Initially, we can say we have to include characters. So in order to include characters, let's start including from the 0th index itself. That is from the starting. Although we will have the excluding pointer, the right pointer will be the including pointer. Left pointer will be for excluding. Left pointer will also start from 0 because if we want to exclude later on, we have to exclude from 0th index itself. And initially, you can say the maximum length will be 0. How many characters are there in the current substring which are not repeating, or actually even if they're repeating, how many are unique? We have to maintain the unique count also. So as you can see in the current substring, which is actually empty, there are 0 unique characters. Till now, we have not started. First, we will include A. If I will include A, the A's frequency will become 1. It is occurring for the first time. And also the number of unique characters will become 1 because it is the first character. Is it less than equal to 4? Yes. So answer will also become 1 length. Right minus left plus 1. 0 minus 0 plus 1. 1 length. Only A string. It is having less than equal to 4 unique characters. So we will try to include the next character. We will try to include each and every character one by one. If I will include B, can I include it? Yes, because it will only have 2 unique characters. Or you can actually say the unique will be also getting from the size of the hash map, because the number of key value pairs in the hash map denotes the number of unique keys, because hash map will only contain unique keys. So no need to maintain the unique variable also. You can just get the size of the hash map. So since there are 2 keys, 2 is less than equal to 4, it is good. And what is the length? Length is 1 minus 0 plus 1, 2 length. The substring is of 2 length. Can we include C? Yes, it is not occurring till now. The hash map length is 3. It means there are 3 characters. Different characters are there. So good enough. And answer will also become 3. Can we include B again? Yes, although the frequency of B will become 2, but still the hash map size is 3, less than equal to 4, we can include it. Length will become 4. Can we include G also? As soon as you include G, the hash map size becomes 4, equal to K. Still it is good because it should be at most K. And now the length is 5, right minus left plus 1, 4 minus 0 plus 1. So still good enough. Now, but as soon as I include the character E, if I am going to include E, what will happen? The number of unique characters will become 5. Why? Because the number of key value pairs in the hash map will become 5. So now we need to discard characters from left, because we discussed we can't just discard from same end. So first discard A character. If I will discard A, I will do frequency minus minus. While including, we were doing frequency plus plus. While discarding, we will do frequency minus minus. And now since A is having 0 frequency, let's just delete it from the hash map so that it is not just getting the size of hash map as more than 4. So as soon as I delete A, that is do right, the left pointer actually plus plus because it is discarded. Now again, the number of unique key value pairs are 4 only. That is good. Although the length is only, you can say 5, which is already the answer. Do not update the answer. Next character is F. Can we include it? We have to include it always, but after including it with 1 frequency, again the hash map will become 5 size. Now I have to make it again 4. That is at most 4 I have to make. So again discard characters. First discard B, all the frequency will become 1. It is not completely discarded. Discard C, the frequency of C will become 0. And as soon as I discard C, the number of unique characters will become 4. 1, 2, 3, 4. So good. What is the string length? 4 only, not greater than 5. In this fashion, we have to include and exclude. Let's just quickly do the dry run for the remaining string. If we will include G, the number of unique characters will again become 5. So again, discard characters. First discard B. If I will discard B, the frequency will become 0. So delete it. Again, the number of unique characters will become 4. And we can say, actually, G was already present. We don't have to do this. G was already present with 1 frequency. So don't discard B. We can just have B already, because number of unique characters will still remain 4 only. So what is the length? Length is 5. This third index will be the left pointer. B and G, E, F, these are only 4 characters. But now when I will include A, that is the point, the number of unique characters will become 5. So keep on doing this again and again till we are getting the maximum length. So as you can see, I'm not going to do the complete dry run. You can just take the string till this point. We can say the maximum length will be in the answer. In how much time are we able to get it? We are just running a simple loop over the input string. And as soon as the right pointer reaches the string dot length, we can stop because we have included each and every character. Although the excluding character pointer is also going to run a loop, it will be a nested loop, but still time complexity will be linear. Why? Because both these pointers will not run in a nested fashion. It is not like when right is at 8, left is going from 0 to 7. When right is at 7, left is going from 0 to 6 and so on. No. When right is becoming plus plus, Left may or may not become plus plus, but when left is becoming plus plus, it will not go backwards. If it is becoming plus plus, it will just move forward only. So both the pointers will move forward for n times in worst case, and n plus n will be 2n. Overall time complexity will be linear, but when it comes to space complexity, we can say that we are using a hash map, which is extra space or auxiliary data sector of order of 256 different types of key value pairs in worst case, because at most these many different characters can exist, 256 characters in a sky code. Although, if we include Unicode or if we consider the array of integers instead of array of characters or the string, we can say the space will also be linear. It is just a matter of perspective that are you seeing as it as a perspective of different characters. Since different characters can be at most 256, usually in ASCII codes, so you can say it is constant. Or if you are taking it as a perspective of the array size or the string size, you will say it is linear space. So both are correct answers. You have to just explain it accordingly. Now let's do what? Let's write the code according to the approach which we have discussed. Not the code, but actually the pseudocode. That is the instruction manual. First of all, we have to create a hash map of key as character, and value would be nothing but the integer, the occurrences, the number of occurrences. We will say just maintain 2 pointers, but second pointer, that is the right pointer, to include, we can just have it in the loop itself because it will include every time. But for right, the left pointer will only exclude sometime. So let's make it outside the loop. So set a left pointer as 0, and also the maximum length we need to store. So answer we need to store. So we can also set that as 0. We will try to run a for loop. Run a for loop over right index from 0 till the string dot length -1. Two strings last index, that is n-1 string is of n characters. Whatever right character we are having, just include it by doing frequency plus plus. Include right character by doing frequency plus plus in hash map. But as soon as you included, check what is the size of hash map. Check if size of hash map is less than k or less than equal to k actually, or more than k. If it is more than k, then we have to discard characters. So we have to keep on discarding characters till the size again becomes less than k. So we have to actually run a loop. So we can run a while loop. While loop will be a better option because we don't have initialization as such. So run a while loop till the point, till the size of the hash map is more than k, till it is having more than k unique characters present in the substring. And discarding loop will be on the left pointer. Outer loop is for including, which is right. Inner loop is for discarding, which is on left. And we will keep on discarding by doing the frequency minus minus. So exclude the left character. Exclude the left character by doing frequency minus minus in hash map. But check if the frequency is 0, then delete the key value pair. Then delete the key value pair. Delete the key value pair also. And as soon as the size becomes less than equal to k, we can say that we are able to get the substring with valid conditions. So stop the loop. So after the loop is done, and actually while we are excluding the characters, we also have to do left pointer plus plus because we will keep on discarding the next index. After this loop is done, we are having a valid substring. So we will check the substring length. So check the substring length. Check if the length of substring, that is nothing but what? That is nothing but right minus left plus 1 as discussed in the dry run, is more than answer or not, is greater than answer. If yes, update the answer. Update answer as length as right minus left plus 1 itself. But after doing it, we have to also basically just return the answer. That is finally when we are able to get the longest substring, we will return it, the length only. So we have already discussed the instruction manual. Using that, we will be writing the code in Java programming language. So let's just directly jump onto it. So we have to first of all create a hash map, as you can see in the instruction manual. Having the key as character, having the value as integer. Let's say the hash map name is HM. And what we need to do is, initially hash map will be empty. We need to set two pointers, left pointer and right pointer. Although right pointer will be within the loop, left pointer we can set it outside the loop because it will be sometimes updated. We sometimes have to discard characters. And also the answer variable, which will store the maximum length, the longest length will be at 0th index only. That is not the 0th index, but the 0 length, empty length. And right pointer, we will run a loop because we can have a right pointer every time including a character. So we can have a simple for loop for it. So right pointer will be just having a for loop going to each and every index from 0 till string dot length. And we will one by one include it, the character at right, by just doing the frequency of that character plus plus. So we will get the frequency, whatever the frequency is, we will do frequency plus 1. And if the frequency is not present, we have to consider it as 0. So what we will do is, we will say hm.put, put means insert or update the frequency of the character. The character is s.char at right, the character at right. This is the function in Java. What should be the new frequency? The new frequency should be the old frequency for same character plus 1. So for that, we can store it in a variable old, which will be the hm.get old frequency of the same character s.char at right. But if the character does not exist, what does Java do is Java will return you null. If the character does not exist, it will give you null value instead of 0 value. Although in other languages, it will give you 0. So if you want to get 0, you have to use, instead of get, you have to use get or default function. And in that case, you have to pass a second parameter, the default value, which you should get if the key is not present. And the value which we are trying to get is 0. If the key is not present, we will get the value 0. Whatever the old value is, we have to do the frequency plus plus by making old plus 1 as the new frequency. So these two lines will do the frequency of the character at right plus plus, that is include it. But after including it, we also have to check whether we have included more than k characters or not, more than k different characters or not. So for that, if the number of characters which are included are more than k, then we have to discard them. And how we can check the number of characters which are included? By getting the size of the hash map. If the size of hash map is more than k, now the point is we have to discard characters, exclude characters using left. And for discarding, we can do the same thing as done here, but instead of just making the frequency as the character at right, we have to do at character at left. Similarly, at the next line also, instead of the right character, we have to do left character, but old frequency should become minus minus. So old frequency minus 1. But one more point is that if the new frequency is becoming 0, in that case, we have to delete it also. So when it will become 0, if I will say old minus 1 is 0. So if old minus 1 is 0, or you can say old is the 1, that is after updating it will become 0. In that case, delete the character also. So we can say hm dot remove might be the function name, which will remove the character at left. But if even if we are removing it, we are not removing it, that does not matter. We will always do left pointer plus plus because we have discarded it anyways. And once we are able to get the substring with valid characters only, k at most distinct characters, we will check whether the current substring is of maximum length or not. So if right minus left plus 1 is more than the answer, what we will do is update the answer. Answer will be right minus left plus 1. Or you can also use maximum function. So let's do what? Let's just return answer and see if it is going to pass all the test cases or not. Why? Because there might be some corner cases also which we need to take care of, or maybe they are already taken care of, that we need to see. So it is taking some time to run. Hopefully it should give no errors, but there is a small error. In the hash map name, there is nothing like hash map with M small. We have to make a hash map with M capital, H capital, M capital in Java. Let's run it again. And this time, hopefully there should be no other error. Okay, actually there are multiple errors. First error is the variable old is already defined. So what we can do instead of storing it this time inside the inner loop, we can say that now we don't need to use get or default. We can just directly get the old frequency by using get function, because we are sure it will be present in the substring because it was already included. We are when we are discarding it, it was already included. So we can get the old frequency by using hm.get the s.char at left, because it will already be present. So no need to use a default value. It will never give you null. And there was one more error, which was regarding the left or right pointer. Let's just run it again to see if there is any other errors or not. So there is some error with regards to answer variable. So ANS is not existing. Actually, the variable name is answer, not ANS only. So let's change the variable name with the complete name. So these are small errors with regards to data types or variables or the syntax errors only. Although when we run it, we are getting a null pointer exception. And why it is getting a null pointer exception, that we have to see. We are getting the old frequency of the character. If the old frequency does not exist, we have to take it 0 and put the character's new frequency as the old frequency plus 1. And if the hash map size is more than k, in that case, we have to put the character at left with the old frequency of the character minus 1. But now check whether the old is 1. But old variable is the outer old variable. We have to check it for the inner thing. So for that, we can actually use the get function. Whether the frequency is 0, that is hm.get the s.char at left. The characters at left frequency, is it 0? Now after updating, we have to check for 0 only. Then remove it. So hopefully it should not give me null pointer exception now, because we were wrongly comparing the old variable. So as you can see, it is giving me 3 for the sample input. Let's just submit it and check whether it is going to pass all the test cases or not. It is taking some time to run. There might be a lot of test cases. And as you can see, all the 31 test cases, including the corner cases, base cases, everything is getting passed. And this is the code taking how much time complexity. We are running a loop over the string of length n. Inside that, we are running another loop. But even though there are 2 loops, they are not dependent on each other. They are not running in a fashion that whenever outer loop will run, inner loop will run completely. No. This loop is also running for n times. Independently, this loop is also running for n times. Both the pointers, left and right, will just complete the iteration once. They will never come back to the previous index. They will never move backward. So n plus n will be the overall time complexity. Why? Because get or default, put, get, all these functions, even remove, all these functions will be average case constant in nature. And since all these operations are constant, overall time will be only due to the loop, which is only, you can say, linear. 2 times linear is still linear. But when it comes to space, if there are 256 different types of characters, if you are including only ASCII characters, so there will be the space complexity as order of 256. Although if you don't say that there are only ASCII characters, if there are more characters also, Unicodes also, or if there are, instead of string, if there is an integer array, in that case, you can say the hash map space will be linear. It is just a matter of perspective, how you are thinking. So due to hash map, there is extra space. There is auxiliary data structure for sure. So with that, we are done with the problem. Longest substring with at most k distinct characters. You can try to do a dry run using this code on different test cases, on having test cases with some corner scenarios also. And I think you will be able to get the logic